Welcome back to part 7 in our series on how to build a copper still, where we will be assembling the collar, column, and condenser. This type of still can be used to make water, essential oils, fuel alcohol, and even spirits. Although stills like these are often called moonshine stills, they can't actually be used to distill alcohol without special permits. Okay, so we're going to shape the collar, which will fit inside of the vapor cone there, and it's important to lap this piece properly. Essentially, you want to lap this part the same way that you lap the skirt, so you end up with a very tight fit once the still is finished. So we're going to bend this by hand. You will start by gently folding the edges together to make sort of a C shape and then a U shape, and then you'll end up with more of a, well, exactly an O shape once you're finished. And this is what it should look like. Once you determine how the piece needs to be lapped, set it down inside of the vapor cone and spread it apart as much as you can. You want it tight up against the vapor cone there as possible, and then just mark it with your pencil or a pen or a Sharpie or whatever. Then pull the piece out, apply some flux to the inside of the lap, so the parts that will be touching, the pieces of copper that will be touching one another, should be brushed with the flux. Clamp it with a little pair of locking pliers and just give it one last test fit to make sure it's not too big, not too small. It should fit in there very snugly. Then you'll hit it with the torch. Very low heat on this one. Keep the torch far away, keep the heat down low, and let that solder flow into the seam. This is what it should look like once you're done soldering. Okay, now that you have it soldered together, let it cool down to the point that you can work it with your bare hands and shape it one last time. Try your best to get this thing as perfectly round as you can. The part that's probably going to need the most work is the area where you soldered, the part where the pieces lapped together. That looks pretty good. I'm going to test fit it with my cap skirt. The ring should rest on the cap skirt about halfway up between the two rivets of the skirt. It's important to test fit this piece, keep the skirt upright, pop it out, and then push it down into the vapor cone, because if you flip that collar over, the lap will be backwards. All right, you know what, and one more thing I'm going to do here, because this part's been sitting around for a couple of days, it sort of started to tarnish again just a little bit. I'm going to hit it with some sandpaper just to make sure the surface is as fresh as possible. This will allow the solder to stick to the copper much more easily. All right, so I popped the piece in here. I'm going to do the final alignment. You're going to want the lap of the collar to line up with the lap of the boiler below. You want it to be flat, essentially. You don't want it tipped to one side or the other. You're just going to have to eyeball this. Make sure that you have an even reveal between the vapor cone and the top of the collar all the way around the piece. Once you have the piece in there as you want it, you will hit it with some flux, just like we've done everything else. And here, this is a very important step. Throw those locking pliers on there one more time. I've put enough of these together to know that this is the best way to do this. It's entirely possible to overheat the lap there and have that collar pop apart on you. So I have the torch turned down pretty much as low as I can get it. I'm applying some very light heat to the back of the collar here, and I will just heat it until it gets hot enough for the solder to melt, and then I pull the torch away, just like we've done everything else. So we'll just make our way around the still here. You may have to hit the front of the collar and a bit of the vapor cone occasionally to get the solder to melt, but for the most part, I like to concentrate the heat on the back of the collar. So here's something that will happen from time to time. I left the torch on there just a little bit too long, and some carbon or some soot started to build up. It's very difficult to get solder to stick to anything that has been scorched. hit that section with just a tiny bit of flux, and that will clean the scorching off, which will then allow the solder to stick again. Now I've made my way back to where we started. Okay, so I just made a huge mistake. I accidentally hit the stick of solder itself with the heat of the torch, and a huge chunk fell off and melted on the vapor cone. So what I'm going to do here immediately is I'm going to see how much of that I can brush off. I got some to come off. Okay, so I've just made things worse. I try not to do this. I try to be more careful with my joints. I made a mistake there. What I'm going to do is I'll show you how to fix this problem here. I'm going to keep working on the collar here. I'll wrap it up, and then we'll come back and I will show you how to fix screw ups such as these. So 2 thumbs down on this one. I made a huge mess on the vapor cone. So here's a little bonus tutorial on fixing ugly solder spills. This seems counterintuitive, but the best way to remediate these situations is to actually make a much bigger mess than you started with. But essentially what we're trying to do is heat that solder up and brush as much off as we can. Also, we want to spread it out as thinly as possible on the vapor cone, because what I will do when I'm completely done building the still is I'll just take some really fine grit sandpaper and I'll sand that flux right off. All right, now that I'm done cleaning up my mess, I'm going to continue with the rest of the build. I'll be assembling and soldering the column and condenser. The first thing I'm going to show you are the 2 column options. I'll just go ahead and pop the 1.5 to 1/2 inch coupling on the piece of 1.5 tubing. I'll put one of the T's on the 1/2 inch tubing. I'll pop the 3/4 inch piece of tubing in the middle there, and then I'll cap it with the other 1/2 by 1/2 by 3/4 T. And you want to sort of evenly space this from end to end, and then also the side ports should be lined up. I'm going to grab a 90-degree street and put it on one end. It doesn't matter which end. I put the 45-degree coupling on the other end facing the opposite direction. Here is option number 1, the no column thermometer option, just our standard setup. Place the final 90-degree street on top of the column and then slide the condenser into that. You don't technically need a thermometer to distill, but they are handy. This is how you would assemble the column if you were choosing to not install a column thermometer. Option number 2, the column thermometer upgrade. This upgrade is available for purchase when you buy the still, or you can buy it as a standalone add-on. It's the same configuration with the addition of a few parts. To set it up, simply take the 90-degree street out of the 1.5 by 1/2 inch coupling. Put one of the 1/2 inch stubs in the coupling, place the T on top of that, place another stub and the threaded coupling on one side, and then slide the 90-degree street on top of the condenser into the side of the T. This is the option that we're going to solder together during this build, and this is what it will look like when we're all done. Okay, so moving on. Clean the column and condenser parts before soldering. Again, very important step. If you cleaned all of your parts at the beginning of your build and they've just been sitting down around for a couple of days, it's actually not a bad idea to clean them again. If you haven't cleaned them at all, then it's a good idea to do that now. Solder sticks to clean copper much more easily than it does dull or tarnished copper. So this is a very important step. Just use a wire brush and some fine grit sandpaper and hit the outsides of the tubing and the insides of all of the couplings. We'll begin by attaching the 1.5 inch column to the cap plate. It's easiest if you flare the end of the tubing out so it friction fits to the cap plate. I'm going to take my ball peen hammer and just tap the inside edge of the tubing to flare it just a little bit. So when I drop the tubing into the cap plate, it actually sticks. I am going to take a second to clean the inside and the outside of the plate. Again, I'm going to use some fine grit sandpaper. So I'm ready to solder. I'll drop the column in one more time. Everything's cleaned up. I friction fit it. I'm going to solder from the inside, which is the easiest way to do this. To keep the part stable while I'm soldering, I'm going to secure the column in a vise. You want the end of the column to be flush with the cap plate there. Apply some flux to both sides, the inside and the outside of that joint where it meets the cap plate. And heat the column only. When soldering this joint, only heat the column. It's a bit difficult to see here because of the angle, but I'm not applying heat to the cap plate at all. It is very easy to melt the solder between the cap skirt and the cap plate. You'll be able to transfer enough heat from the column to the cap plate to get the solder to melt and stick to both. And if you watch very closely right here, you'll see the solder between the cap plate and the cap skirt change colors. That's exactly why you don't want to apply heat directly to the cap plate. Moving on, I'm going to assemble the condenser. It's best to apply flux to all the parts as you're putting them together, which is what I'm doing here. Again, the 3/4 by half T goes on one end of the 1/2 inch tubing. The 3/4 inch tubing goes on after that, and it gets sandwiched together by the other 1/2 by 3/4 T. Make sure that there's an equal amount of tubing hanging out on both ends of the T's. Alright, before I begin soldering here, I'm going to pop the 1/2 inch stubs into the side ports on these T's after I clean them and add flux. I'll make sure that the stubs are aligned as I mentioned before, and then I'll go ahead and start heating the parts and soldering. I like to start with the connections between the 3/4 inch tubing and the T's, and then I'll move on to the 1/2 inch connections and make sure you solder all of the joints. Once I've finished with one side, I just move on to the next. Then I'll put my 45-degree coupling on one end. It should be angled up, facing the direction that the ports are facing. And the last thing I'm going to do here is install the 90-degree street on the opposite end of the 45-degree coupling. Align it so it is parallel to but facing in the opposite direction of the 45-degree coupling. Go ahead and heat that up and solder it together. This is what the condenser should look like when it's finished. From here, I'll move on to the column. I'm just going to go ahead and slide the 1.5 to 1/2 inch coupling on the end of the column. Heat that up, concentrating most of the heat on the coupling itself, and I'll solder it together. Again, I've cleaned and I've added flux to these parts. Then I'll tilt the column upright and I'll install one of the 1/2 inch stubs. I'll put the T on top of that. I'll put a 1/2 inch stub in one of the side ports of the T and the NPT copper pipe fitting on the end of that. And I'll solder everything together. Then I'll solder the connections between the stub and the T and the coupling. All right, and the last step here is to join the condenser and the column. So orient the column like this. I'm going to go ahead and clean this joint out here just a little bit. It looks like there's some buildup of some soot and whatnot in there. And I'm going to clean the joint of this 90-degree street as well. I'll apply flux to both. Just slide the condenser into the open port at the top of the column there and find something to place in between the column and condenser so there's an even amount of space all the way down between those two parts. I'm concentrating most of my heat on the T here. And I'm done. Okay, so I'm going to go ahead and place the column into the top of the still here. Just one note, the column and condenser do not get permanently attached to the boiler and the vapor cone. This is so you can open and close the still, allowing you to fill it, empty it, etc. Okay, check out part 8 in this video series on building a moonshine still, where we will install the boiler thermometer and we'll clean the still.